Miss Ashley Payne's going to come up and introduce our next speaker.
Hello again. Please join me in welcoming Mr. Scott Pickett, who serves as the Vice President of Product and Service Delivery at TSRI. Scott has cross-industry experience working around the globe with organizations ranging from startups to enterprises, and with products and solutions ranging from embedded software to configurable logic, networking, communications, and systems. His most recent deployments are centered on application modernization and cloud migration for TSRI. So please welcome Mr. Scott Pickett.
Okay. Well, I didn't have a joke, but I do have a story. So, I lived as a teenager in the South Pacific, and I surfed, and I surfed for about a year and a half, and I felt pretty confident and felt like I was getting it down, and I'd looked at this one break next to this island, or this rock outshoot from Funganania, and it looked like a perfect break, and it looked like it was small and something I could take on. So I hadn't been there before, and all of a sudden a huge set came out. It was about 50 yards ahead of me, and I couldn't make it out, and all of a sudden coral heads were popping up next to me on both sides, and I just got trashed, just tumbled and pummeled and pummeled. And I lost my surfboard, my ankle was wrapped around a coral head, and barely made it to shore. So what's that have to do with software modernization? Well, I learned some lessons. Probably the biggest one is, before you go into any type of project or any type of a significant outing, kind of understand it and have some experience in that environment, with that challenge. Be in a situation where you can understand the risks, understand how you can get out of it, understand what position you need to put yourself in to get out of it before it's too late. It's always a good idea to have kind of a good skill set. In this case, I was not prepared to be able to do that at that time, and have the discipline you need to be able to physically get out of it, or the skill set that you need to, and then go with someone with experience. So what's this have to do with software modernization? Well, in today's environment, a lot of IT managers and officers and CIOs are facing huge challenges. They have aging systems, depleting workforce that has knowledge of those systems. Sometimes they don't even have anybody that understands what's operating on the mainframe. There's a diminishing amount of resources that are able to even work in that environment. They're underinvested in those environments over the course of the last 20 or 30 years. There's continued demands in those environments. You're in a situation where population, the clients, the workloads, they're all increasing, but the systems are not able to keep up. There's limits on what you can apply to those particular environments. And it's difficult to be able to move into a modernized environment where you could use best-of-class CI/CD pipelines, best-of-class services. So you're kind of pigeonholed and stuck, and in addition to that, you have software vendors that are, I don't want to say taking advantage of, but they're certainly not lowering their costs for their licenses. So you end up in a situation where it's getting more and more expensive, you have to make a larger and larger investment, and the debt that you have is actually more than you see. It's just like the classic accident. And you have to address it, you need to address it sooner rather than later. So TSRI is a company that's focused on software modernization. And we use an AI-based model to be able to modernize software, but it's not Gen AI. We've worked on a number of different projects over the last 25 years. The company was born out of Boeing AI Labs, and it was really the first The first major project with the government was Y2K mediation. That was kind of like the big first project. So it's been around for some time. We've done a number of different federal and defense contracts. I've been involved with several, and also working with the defense industry and working inside SCIFs. We have people with clearance and bringing up our tools in those environments. Working in the supply chains and modernizing supply chains that are literally managing thousands of clients right now across the country. The Air Force, the Navy. But in addition to mainframes, we also go through and do the modernization of embedded systems. Many of those embedded systems are using languages like Ada, which is quite sophisticated language actually, but it's also very old and not too many people know it. And we have a gateway to support that. We're supporting embedded systems, flight control systems, missile control systems. And so we've done a number of these, and I kind of encourage you to go and look at 7 or 8 of our case studies. Talk to Adam over there in the corner. He's got those case studies, and you can see exactly what they were, in which projects were completed and how large they were. We're also obviously in the commercial space as well. This is a tool set that goes across all verticals. And in the defense industry and the federal government isn't the only one that has these problems. The financial institutions are also on mainframes, also has legacy systems, and are also with, have the same challenges. So it's not just, the mainframe that are applying to the government and defense sector. So it's quite a roadmap that we have, though. If you stand, I've done probably 4 of these projects in the last 8 years. I've been at TSRI for 8 years, and most all of them have been very large. I've worked on the HUD project and a couple of the Boeing projects, and I'll be able to answer any questions on that. But stepping back, it all comes down to kind of four big steps that you have in these projects. One is the assessment step, and that's where you really got to roll up your sleeves and do a detailed assessment. And I'm not talking about a paper assessment. I'm talking about getting the code, reviewing the code, finding out all the dependencies, finding out exactly what makes that code run. The truth is in the code. And then until you get to that level, you'll have unknowns. And even when you get to that level, you'll still have unknowns, because some of those implementations are archaic, old, proprietary, in assembly. So you'll have to kind of unwrap that as well. So there's the assessment phase. And then in the assessment phase, you'll go, I'll talk about this in a moment, but you'll get all the information you need to take the next step, which is the transformation phase. And it's a model-based solution, so it's a tool. So you'll be able to run it again and again over the course of the project. So you'll be able to do updates, you'll be able to do updates, baselines, you'll be able to do updates in partial. And so it's a tool that's used. And it uses rules to be able to operate on that model. And then you get into the kind of the 3rd and 4th phase, where you're actually doing deployments, doing the testing, and what I call partial go-live deployments, where you don't do the big bang anymore. You don't take the risk. You don't take the risk and the stress to go through and do a huge deployment. You do it in pieces, and you do the right piece that you need because it's already been tested and validated. And I'll talk a bit about that and what success cases we've had. So you step back at it, you have multiple different deployment phases at the end. So, the assessment, what's that all about? This brings together probably 3 fundamental things. You're going to look at the financial risks, the financial challenges, the financial requirements, the licensing costs that you have now, how you can alleviate those license costs in the future. So there's the financial part of it. There's the technical debt. There's technical risk associated with that. You need to really go into the detail on that technical debt. You need to get agreement on what the actual, I'm one slide off here, excuse me. You need to get agreement regarding your actual phasing of the deployments. So those are all wrapped up into a formal assessment, and you really want to get into the details, and don't be afraid of it. I mean, there's situations where that can be overwhelming, but you want to have detailed transformation plans. You want to have details on all the externals that are required for the system to work. What are externals? Externals are referenced in the code that's operating on the mainframe, but you may not have the sources to it. So it might be a sync or a sort or a system utility or a backup utility. So you have to come up with strategies for all these utilities that are in the legacy that aren't necessarily there in the target environment. You have to come up with detailed strategies on each one. There may be 50, 100 of those. That's all doable. It is just code at some point, or interfacing to another application that's implementing that function. So you end up having to have a resolution plan for all of the externals. You got to take into account the project timelines, the resourcing, the skill set, and the environment. And those are all a part of this transformation plan, and also allows for kind of the target workshops. The workshops that are going to tell you this is what it needs to look like. This is what we want it to run on. What cloud vendors could be supported, what underlying services. When you go through and get visibility at that level, you'll also understand what's no longer required. There are a number of different services that are being offered that you might do differently when you go to a new environment. Printing functions, backup functions, messaging functionality. Those will probably be better suited if they're obsoleted on the mainframe and replaced with newer services, or not replaced at all because you have a different type of backup mechanism in the cloud environment. One of the other things that you need to look at up front is what phases you're going to go through when you do the deployments. So again, don't do the big bang. Take the thing that you can get tested and deploy and prove out as your first deployment. Nail that, and then roll out with the next phase, which is another spiral, which might be another 1,000,000 lines of code. But you'll be able to incrementally add that on in a growing spiral. They're all aligned with this planning process, which is similar to a product increment planning that you use in the sprint process. So you go through and have this assessment, you have the detailed plans, you've got your resources and everything all kind of lined up as far as what experts you need when. You know exactly what your implementations are going to be. Now you're ready for the transformation. So TSRI has built this tool called Janus Studio, and it supports a number of different gateways. These are language gateways that's able to go through and do the parsing and lexing and bring it into a language neutral model. Once it's in that language neutral model, we can go through and write out reports, we can find out dependencies, we can also go through and target new code. And typically that's going to be in something like Java, C#. We do support C++, that's still popular, in Python. But those environments will need to be, or that code base will need to be refactored. And we'll talk a little bit about the type of refactorings we do. Typically it's going to be for maintainability and supportability, so that people coming out of school will be able to support that code base. There might be new design patterns that you use to be able to support containers. You might inject REST endpoints so you can interface with those containers, and those containers can support new DevOps pipelines that allow for continuous deployments. You'll separate out into services so that they can actually support a database service, managed data service, as well as the business service and the presentation service. So it all scales out like it would in a cloud environment. So you're doing several different types of refactoring at this phase as well. So what's the guts look like? And I'll just spend a moment on it, but it is a model-based approach. I was going to try to make a funny comment, but not all expert systems are bad. You do have rules that take experts that actually write against the model. That's the big difference between one of the big differences between an LLM and a deterministic model like this. You know exactly what you're operating on from one model to the next. There's no probability. There's no. It's a high fidelity. You know exactly what happened to change from a COBOL or from Fortran over to C# or Java. So the initial phase is to get it into an abstract syntax tree that still has a bunch of constraints needed to be applied on the constructs of the old language. Then you're able to get it into a language neutral model. Once it's in that language neutral model, you can manipulate it with these rules and allow you to do refactorings. You could take out nested loops that were okay in a mainframe because it was all just running in the same system, but those nested loops, doing database calls within a nested loop, are now going back and forth across an entire network and a database and not gateways, come on, it's back. Anyway, load balancing, application load balancers, and then coming back, and it's inefficient, so you can go through and remove those type of nested requirements and do refactoring without changing the business logic. And then you'll go through and take the next step to actually target the new environment. What we're doing now is applying our same basic tools in addition to being able to generate high fidelity code, but also get you leveraging Gen AI, but also get you to a point where you can get business logic and business rules. So we're basically following up with being able to extract out a knowledge graph from the source, and having the source be able to pipe that into a vector database, and then running that into a prompt engine that goes through and drives an LLM. This is a proprietary LLM that we own, but it's still leveraging kind of the OpenAI LLM model. And then from that, we're able to get business reports. So now, just because your SME might no longer be with the company on the COBOL, you now have something that you can read in English that's a representation of that COBOL. And that could be used side by side next to those graphs that I was showing you earlier, and all the blueprints that you have to be able to go through and really understand the language. You also have side by side blueprints that will show you the old legacy code and the target new code as well. Two other things. We extract out metadata from the actual code. And what that gives you is all of the requirements that you need from an input-output database update external interface in order to test it. So you have the basis of being able to do a functional equivalence test. And then you're able to, from the LLM, you're able to generate initial data for the actual population of those tests. So there's another kind of step that we're using, not to generate the code, but to actually give you information that you need to know about the code using LLM and Gen AI, and also the ability to go through and extract out information for testing. What is automated refactoring and why? So it kind of breaks down into a couple different categories. I think I last checked, the company had something like 2,500 different options, and way more than you could put in, not even a book. But there's literally been 2,500 different refactorings that we've applied on those 250 or 300 now projects that we've done. And each one of those options represent a change that was made based on the customer and the project. And they break down into these categories. First, the automated refactorings associated with the architecture. So here you want to put in a separate database layer. We want to interface to a DAO, and I'll talk about why that's important. You want to be able to do separation of the business logic from the presentation tier. And you want to be able to support things like dependency injection, so you can be in a container and support microservices. You want to pass all the scans that you need for code quality and security. That's like, you have to be able to do that. You need to be able to do modern language. You need to be able to support the modern language. Got to get rid of the go-tos. Change over to Swish statements. Where possible, you need to consolidate. What you'll find is that people over time had just replicated entire programs within the same application just because of the name of the customer. Or just you're looking at like, well, there's like 30,000 lines of code that's the exact same. They just changed that because there was one new service or one new customer. So that can get consolidated. There are also cases where there's all sorts of POCs and stuff done that's in the code base that's not even referenced. You can't even get to the code. They just don't, it's in there, but it's not being used. It's absolutely dead code. It's obsolete code. So we identified the areas where you can collapse code. We've identified areas that's referenced, or it's not referenced and unused. Same thing with the data structures as well. There's a lot of that in COBOL, where they just replicated an entire table. And now you can change that to have a key for that specific customer instead of having a replicated entire table for some small change. And then supportability. There's just a number of different changes that are required to be able to make the solution more supportable. Sometimes it's organization, sometimes it's directory structures, sometimes it's naming conventions. If you've ever looked at a lot of old COBOL, it's a very terse type of naming. It's AD4_612, and it turns out it's a print file for the IRS or something. It has no logical bearing on the actual content. An SME can go give us information regarding that. We feed that CSV into our model and automatically replace it based on the SME's knowledge or heuristic. Okay, so code quality, as I mentioned, we go through security scans, vulnerability scans, code quality scans. Our objective is to get AAAs. Because it's a model-based approach, you don't end up having to have human beings make those changes, which can be error-prone. And also the model can be applied across the entire code base. So you actually eliminate debt in hours instead of days and weeks. So these are actual transformations that were done that we were able to get kind of quadruple A's across the board for SolarCube scores. Every project's got a database requirement. I don't want to say don't do it, but the first phase, what you want to do is keep the schema the same. You want to minimize the type of normalization and database refactoring up front. The reason why is because you don't want to change the business logic. The business logic and the schema work together, so just basically support the current schema. After you have that functional equivalent, then you can go through and make changes. And we do a lot of things with respect to different field operations, and data type identification. One of the other things that's really important is supporting multiple DAOs. So what's that mean? We developed an abstraction layer that allows the code to operate with different databases. So that means you can move the code over and still interface with the mainframe database. So there's no risk in data migration. So you just decouple that risk. We've got one large customer in Europe that went live interfacing with the database for 4 or 5 years before they finally migrated over. And we have another customer in Europe that is still operating on the mainframe database, and this is after like 5 years. So the idea is that they would be able to change the configuration, move over to the mainframe database, and in almost every project you can over time be able to do that, but you don't have to do it. You don't have to risk your database migration. And then obviously you've got to do all the ETL tools. You got to be able to do a round trip comparison to make sure that every single bit's the same. And if it's a large amount of data, you might have to do incremental updates. So all those things need to be taken into consideration during your transformation and database transformation planning. So now we're at the final phase where you've got your data, you've got your initial code, you define what you want to deploy. What's it look like with respect to your deployment? So functional equivalence testing is critical. You want to leverage the fact that that code has been up and running without a problem for 25 years. So you don't have to go through and reinvent or try to look at some type of new functional driven test case. You just need to make sure it operates the same way. So you just run it on the mainframe, get the results, run the exact same code base off the same database on the new environment, and then compare the results. It's a functional equivalence test. It's a lot easier than doing an exhaustive test. That's number one. You want to be able to automate that test case. So you don't need, if you run it once manually, that's like it. You want to record that and be able to run it again and again and make sure that you can do regressions, and now you've got an asset. So at the end of your actual migration, you've got a test asset that you can go through and change, modify, and grow with and still be able to do regression testing. You can use GenAI, as I mentioned, to actually develop some of those test suites. I want to be able to say one of the things, you got to use a modern CI/CD environment. And that sometimes takes a little bit for some people to set up. But once it's set up, you're able to post these changes, put it in, have quality gates. So now you're automatically triggering unit tests, scans, vulnerability scans, code quality scans, system integration tests, and getting results without having weeks. That just happens automatically, either on demand or nightly. So that's another big part of this, in making sure that's supporting your deployment plans. And then I'm a big proponent in doing this based on containers and being cloud agnostic. You shouldn't get yourself too cornered into one cloud vendor. You'll just be right back in the same situation you are in the mainframe now. So by being cloud agnostic, we can run these containerized applications on Azure, AWS, Oracle, Google, even OpenShift. You can literally run these on your laptop. You can, their Docker containers can run on your laptop now. So you can literally run these anywhere. If you support open standards, common interfaces, and kind of normal best practices. And I have to talk about customers. So, the European Postal Service, how did they go live? They initially went live with one region in one town with just the login. They were so concerned about going live, right? So it was just the login in one town. And those were the only REST interfaces that we would actually redirect over to the modernized environment. Over that summer, they went through all 450 different REST cases, and they got to a point where they were running the entire country. So that was like a big win there. But again, they didn't move the data. They did not want to have any of the data moved over yet. That took years and years and years. But that was a big point. HUD. So what they did was they did one application at a time. They had a number of different applications. They'd migrate one Unisys mainframe application, make sure that's all tested, and that's all deployed. Then they do the next mainframe application. So that's how they would go, kind of one application at a time. I spoke about the European Bank. They did interfaces, REST interfaces primarily around all the externals and forced the mainframe application to support those API interfaces and the modernized API interfaces. So they actually had some development effort on the mainframe that would be able to support a standard approach. Once they're able to do that, they can move over all of the modernized applications and interface to a well-defined, well-supported, agreed-upon API. And they also had a situation where they still haven't migrated the data. They basically turned our charts completely upside down and said, you will not touch the database. Instead of like, you will not change the user, this is, you will not touch our database. So we did all the migration of all the applications without even touching the database, and it's still in operation today. And then there's a major US, very large, it's 48 states, 29 mainframes, and over 36 different plans. I know the one here, and they are doing they're migrating the applications based on functionality. So they're doing the billing first. And then they're going to go through and do the plan profiles this coming, I can't say, but they're doing the plan profiles next. So they're just doing one application at a time. And then what they've done is they've provided a service interface so that their software can operate as a service to all the plans. So instead of a dedicated mainframe for each state or shared states for each plan, they're going to have a provisioning and plan profile that'll log in to a common solution that's offered as a service. So it's kind of moving from a multiple mainframes to a multiple tenant type of environment. And obviously there's a bunch of different configuration on all those IBM mainframes that had to be abstracted out, and then there's some unique customization that would have been done in their job schedules. So all that had to be accommodated for it in order to turn it into a SaaS model. I don't know how I'm doing on time.
If you want to do questions.
Okay, let me just jump. I wanted to talk about the cloud deployments, but we'll move over to. All right, I wanted to talk about the cloud deployments. That's okay, we support multiple clouds. And we support it for batch and online and scales out and a bunch of different native service. But anyway, I wanted to just kind of wrap up. So you kind of the major point was that you can take on these large projects with this basic, it's a basic process that has a lot of different, proven success models. Doing the discovery, understanding the insights, making sure you have an automated solution. That means no manual changes have happened to the admitted code. So it's literally, we try to get to 99.99 as far as the automation level. Very few code changes in the emissions that reduce risks. Try to be pragmatic about being able to support the process, the target gateways, and also when you can bring on your CI/CD pipeline, so it can basically have the services and the environments available when you need them for the code. And then I think I talked about the remediation and being able to continue to kind of accelerate this through automation is what TSRI is all about. So with that, It's a lot of information.
I think there's some COBOL people maybe in the room.
Yeah, does anybody have any questions?
Yeah, I have one. What about the speed of use? COBOL's been around for 60 or 70 years, specifically because it's the second fastest language opposed to assembler, right? Mainframes are becoming more and more back in use.
Yep.
So, I mean, they're even using them for virtual machines now.
So what I can say is that you use modern tools to identify the bottlenecks. So what's that? So you'll use something like an application performance monitor to find out whether or not it's the database server. If it's the database and what you need to do there as far as scaling up the database, adding in-memory capability to the database. You'll go through and understand whether the database is next to your business application and whether or not that's a network connection issue. And then you got kind of the work we have to do, which is making sure the code is performant. And then you run something like a J profiler, and you'll find the choke points. In general, these can scale out, and you can apply larger machines, and they're naturally used, just because of Moore's law, they're scaling up too, and we've been able to solve all these performance problems. So in general, I'd say we've solved all the performance problems, but almost every one of these projects has 1 or 2% of the jobs that need to be optimized, that you have to actually have somebody go through and look at to do these profilings and understand how to leverage new refactorings. One other point there, you're actually able to do some other things when you leverage the cloud too, which is caching. So you'll be able to do in-memory, and then you'll be able to cache information on the business logic, and you're able to cache information on the client side. Those are all tools that you can apply. I can say though that you're never going to be as fast as how fast a screen comes up on a mainframe. I mean, you're bringing stuff up in a browser, it's never going to be faster than a Google. It's 1.3 seconds. You're never going to be faster than that. And when you bring up a screen on a mainframe, you can bring up a screen instantaneously. That's a little excited about that. But yeah. So anyway, the point is that there are constraints with respect to the architectures, but we've been able to resolve those through caching and refactoring and profiling, and we've gotten through them all on all these projects.
Yeah, because we had an example of it at one point in time, a 20-minute job, was converted at one point in time, and it ran 26 hours and it still wasn't done.
Yeah.
That's
I don't want to say similar experiences, but I've had similar experiences, and we went through that process, and some of I mentioned that looping example. So if you're doing a database and you're incrementing within a while loop, and you're doing a database hit, in a mainframe, that's just about instantaneous. When you go to a distributed cloud environment, now you're going through gateways, and you're going through application balancer, and you've got protocol stacks to know the database server, and you're dependent on the network. So you've got to take those things into account. And it turns out we're able to unnest those, and so you can make point-wise business refactorings to resolve that, and you can do that in a systematic way. So that's one of the things that we've had to solve, because mainframes can be inefficient and still run fast. I mean, it's a fact. But we've been able to, we literally, almost every project has a couple jobs. Not that bad, but.
Okay, because of when and how,
I'm sorry.
That's a platform change.
Yeah, and you can scale, yes. That's an architectural platform.
Right. Yeah. So are they doing performance when they change from mainframe to like relational or distributed?
Yeah, yes. So
how about the provisioning?
Well, provisions.
Mainframes tend to use the schema owner.
So
they run from the schema owner on
yeah,
mainframe.
we're able to, you're talking about VSAM or, yeah. So we're able to look at
Oracle.
We're able to look into the code and actually extract out and synthesize a relational database from the target.
Okay.
And have gotten that performant. I think the biggest challenge was with IMS.
Are you doing that when you do the transition there? When you go?
Yes.
Okay.
Yes.
Some people are not doing that.
Yeah, you kind of have to.
Okay.
I mean, you could put a DA in and still point to the legacy, but and that's what we do. People are in production with that.
Are your slides available?
Yes. Yeah.
Do you want me to make them available
That's fine.
Yes, I think that should be fine. It's like,
This gentleman here hit on something as well, about management not switching, having one foot in the past
yeah,
and not for the new technology, and then we have to, you know, kind of train your management for what's new. When you're doing
almost
See,
every,
we got that going on right now.
it's almost every single project, it's like starting a new company almost. You got investors and people that are like, you've got skeptics on the customer side, so, and you've got people that don't want to change.
Right.
We find upper management is, they're the ones paying for the bills, and they're like, hey, we need to change. And middle management be like, there's no benefit in my career to doing this.
But you got,
So
Yeah.
we do see that, and we have to just work through it. We do typically do that with these, with the assessment may come with a POC, so we'll have to prove it. And we have to do a POC, we gotta get it up and running, and it has to be performant. So we often have to prove it in the environment before we actually get under major contracts too. That's,
Scott, you have another question.
We have
I'm
one
sorry.
more question,
sorry.
sorry.
Yeah, because of the way and when mainframes were developed, they are inherently more secure than any of the little machines that came after them where you can elevate privileges and things like that. I was looking for and listening for the word security. Obviously, secure coding was not a thing back when all this code was done. So are you doing anything to ensure secure coding, or are you kind of doing an envelope approach to make the code secure?
So let me try to, I thought I mentioned it a couple times, but I failed. Anyway, so we do code scanning, where you're doing vulnerability scanning. So any of the things that come up with your standard type of scans or industry-specific scans, we'll flag and we'll remediate. That's number one. Number two, you also have, at the DAO level, you also have the ability to encrypt at rest. So you can now have all that information encrypted. And that can either be done as a service, or it can be done in the cloud itself. So we also have people, making sure that none of the data is exposed. And then every one of these projects has a security initiative. I haven't done one that has not had a new security initiative. So that initiative may be keeping with the RACF and wrapping it with a whole new security around the edges and having it in a private environment that limits the amount of users. So it's kind of like triple, three different security initiatives. Maintaining the security that's rules-based in the mainframe, being able to have it in a lockdown environment where you can't access it. You literally, it's in a VPN lockdown environment, and then having additional security initiatives around the edge that allow only certain administrators to have access. So, but it's part of every project, and you can't say one shoe fits all, for sure.
Okay, Scott, one final question and then.
Yeah, just a quick question. On one of your slides, you've listed the target languages being C++, C#, Java, and others.
Python,
Python?
yeah,
Okay,
that's a big one.
I'm curious, do you target any kind of technologies that would be usable by citizen developers? Knowing that,
C#,
well,
Java.
is that really
Python,
citizen developer?
Python.
I know C++ isn't, for sure.
You're thinking about something around a low code, no code.
Correct,
solution.
right.
Oh, I finally get a chance to say this. No. Okay.
Well, the add-on question I have for that too, right? Cobalt's been, and I mentioned it a little bit ago, Cobalt's been around 60, 70 years, right? All of us are getting old and dying off, right? But eventually we die off, or we retire. I'm on board tonight in the sunset. But the new languages come and go all the time, right? What language do we know in a certitude that people are going to be around 60, 70 years later and still know that language?
So interestingly enough, Java is now considered a legacy language.
Right.
And and someone told me it's over 25 years old. Yeah, so it's got a chance. So I'd say probably if I was to pick one that's going to be around for at least another 20 years, I'd say Java.
Java.
But I tell you, C# is pretty prevalent right now. Half of our transformations are targeting C#.
Yeah. And coming and going from the cloud all the time is just click charges. Okay, you have to encrypt it while it's in rest.
Yep.
Encrypt it when it's in transit.
Yep. We do, I
You have all
mean,
that
you don't have to, but it's becoming more and more of the recommended best practice. And so that's,
Anytime you're treating person data, you.
yeah, well, anything that's going out in India, definitely, but within a private environment, when you have a containerized job and containerized COBOL application, that does not necessarily be encrypted. But people are doing it as well, so we are doing that with projects.
All right. Any more questions, please
Okay.
visit the TSRI booth during the